Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous lecture we were discussing the some of the basic types, the data structures that are available in Python. So, let us continue our discussion from where we left in the previous lecture. So, we were talking about the booleans and how they can be used. Now, we will move to the next part, that is typecasting. So, we have certain functions available in Python, the built-in functions available in Python such as str, bool, int, float, which can be used to cast values to those particular types. So, let us start with few examples in typecasting. So, we have this value f value that we had f variable that we had created earlier. So, I will just run this. So, you can see this is the value, this is a floating point number, the value is 1.23456789. So, this is the one that we created in the previous lecture. So, if I want to convert this value from a floating type to an integer type, so I will have to just call this function int, and within the arguments I will have to just pass this variable f. So, if I run this here, so you can see the value floating point number 1.23 and so on has been converted into an integer number that is 1. So, in this fashion we can perform typecasting. So, of course, there is going to be certain loss of information, for example, in this case the floating point number, and when we convert it into an integer number. So, the decimal points they would be lost here. Similarly, another way, if we are looking at, if we want to find out the type of the number that is we just typecasted. So, if we just run this, you can see now the once we typecast a number into a particular type, and the type also changes to that particular type. For example, we typecasted floating point number to integer type. Now, that number will also carry on that integer type itself. The same thing is reflected when we use the type function to find out the data type of that particular variable. Similarly, we have another function bool which can be used to typecast any variable into a bool type. So, again we will use the same variable f to again convert this into a bool type. So, let us run this. So, you can see now this value. So, the value that we passed on to the bool function was a non-zero value, right. So, therefore, it has been converted into true. So, all the non-zero values are going to be converted into true, and only the 0 is going to be mapped to false. All other non-zero values are going to be mapped to true. So, to display the same thing, I am calling in another another cell. So, in this particular cell I am passing on a negative value minus 0.123, and if I run this, you can see again true. So, this is any non-zero value. This is also very small, between minus 1 to 0, and if I just use the bool function, this will also be converted into a true type, right. Similarly, if I pass on the value 0, then I will get the false. So, if I run this, you can see here the result is false here. So, in this fashion we have these function which can actually be used to convert, to cast one type into another. Now, let us move on to the next next aspect, that is this none. So, we have this none data type that typically has only a one unique instance of its own. So, using this particular data type none can be useful in many situations in Python. So, for example, one thing that we have mentioned here is that if a function does not explicitly returns a value, then it implicitly returns none. So, that is inbuilt into a typically the way functions are defined in Python. So, let us take an example here, and also another situation could be that common default value for most of the functional arguments. So, apart from the return value where this none is going to be used, sometimes the arguments they require default value. So, there also none can be used, right. So, that would be the default value for those arguments. So, one example that we are giving here is we are defining this function f2. So, here I have 3 arguments a, b, c, and you can see the default value for c is none. So, this is one of the common default value, and within the function, the first line that we have there is result. So, we are multiplying the first argument a with b. So, a into b. If c is none, we have another conditional logic running here, then result is going to be result plus 1. So, and then we are returning the result. So, if I just run this, so the function f2 is now defined, and you can see now in the first instance of calling this function f2, I am just passing on 2 arguments here. First value is 1, the second argument and its value is 2. So, if I just run this, you can see for the third argument, that is c, default value is already given there, that is none. So, it will run quite well. So, you can see we got the output as 3 because first 2 arguments those were multiplied. So, we got that value. So, now moving on, if we look at the type of this data type none. So, we can just run this type function and pass on none as the argument, and we will find out the type of data type of this particular value. So, you can see none type. So, that is why when I was talking about none, I was also referring to as a data type. It has its own data type which is called none type. So, whenever we are using none, so it has its own type also and unique instance. Now, let us move on. So, next thing that we would like to cover is dates and times. So, we have certain types basic built in types in Python. So, for example, date time, date and time. So, these are 3 typical types. So, date time is typically used more often, especially in the analytics context. So, for if before you can actually use these types, you will have to import these modules. So, from date type you can see here, from date time we will have to import these modules, date time, date and time. So, if I run this, I will have access to all the functions that are part of these modules. Now, let us first start with date time. So, date time is a function that we can use to actually create a date time object here. So, here you can see first thing that I am doing here, I am passing on all the relevant arguments here. So, you can see first I am passing on the year, and then the month, and then the day, and then hours, minutes and second. So, this whole thing date and time both that gives the full information in terms of indicating the date of that particular day and also the current time that is there, or whatever time that we would like to convert into a date time object. So, if I run this, this is the value I get. We created this particular object here. So, if I want to access one of these details here, so you can see the dt date time object that I have just created. I can call these methods here. So, dt dot day to access the day information. So, if I just run this, you can see 29. So, this is the date is 29th here. If I want to find out the month, so I will have to type dt dot month. So, month method will give me the details. So, this is month number 10, and then if I want to access the year, then you can see here 2019. Similarly, for minute, hour and second. So, in this fashion 30 minutes, 20th hour and 21st second. So, each of those elements of this date time object can be accessed using these particular methods. Now, let us move on to the next object that we have. So, next object is date object. So, here you can see here I am using a date method here. So, if I want to find out just the date part of we just saw the date time object. Now, if I want to just look at the date object, then I can use this within the DateTime object I can call this method and we will get the date object. So, you can see here only the date part is shown here. So, this is the object that we get, and if I am just interested in the time part of it, then I can call this dot time method here. So, I will get the time object, you can see here. So, this was about date and time objects. Now, let us move on to the some more aspects about a string. So, formatting date time as a string. So, typically there are various ways we can format a date time string, a date time object as a string. So, here you can see what I am doing is date time object dot I am calling this function strf time. So, this is for str for a string, f for formatting time. So, formatting date time object as a string here, and you can see I am just trying to format using these percentage %m and then forward slash and then percentage capital Y. So, these are to indicate which particular piece of information I would like to have here. So, if I just run this, so you can see the dt value, the dt variable that we had, and only the month and year information is extracted here for is formatted, and you can see full year 2019. So, capital Y actually stands for the full year. If you want to use just 2-digit year number, then you will have to use percentage small y. So, in this fashion we can all the time we can format and extract the kind of date time information that we require. Now, let us move on to the next thing. There some scenarios might require us to actually parse a string into a date time object. So, for this again we are taking this example here. So, for this we are calling this method strp time. So, this is for parsing the string into this date time object. So, here you can see we have first argument is the string 2019, 10 and 18, and then we are formatting, we are parsing this into in this particular fashion. We have given our formatting expression here, percentage y, then percentage m, then percentage d. If I run this, you can see I am able to create a date time object here, where the you can see the date information 2019, 10 and 18 is as per the date time object format, and then 00 to indicate hours and minute that information. So, in this fashion we can actually any string, if it is in that using the formatting expression, we can convert it into the appropriate date time object as well. So, both ways. So, using these methods strf time and strp time, we can format the string both ways, format or pass the string in from string to date time object or date time object to string. So, both way kind of formatting is can be done. Now, if you want to modify a date time object, so next thing is about the same, replacing fields of a date time object. So, here we can use this replace method. So, first argument that in this example we are passing minute. So, you can see here these are named arguments here. So, you can see minute 0 and second 0. So, if I just run this, so I would be replacing that information here. So, in here you can see in the date time object I am able to replace those details. So, minute and second information is gone. Now, in place of minute you just see the 0. Now, similarly sometimes we might require to difference two date time objects. So, that is also possible. So, this particular when we difference two date time objects, what we actually get is a date time dot time delta type. So, it is like the difference between two times and the delta for that. So, the delta, the difference, the delta of that particular time that we will have. So, for that we have this type also in Python, a date time dot time delta type. So, we can use this date time function let us to define another object here. So, dt2. So, let us run this. Now, we have dt2 minus dt. So, if we want to difference we will get this delta value. So, let us run this. So, you can see here you can see the difference between these two date time objects, date time variables and you can see the difference is in number of days and seconds. So, you can see in this fashion that dt2 the second variable that we created, it is actually these many days behind the dt variable, dt object that we had. So, in this fashion we can have even the difference also, difference of date time objects. So, if you want to confirm the type of this particular time delta type, so you can use the type function again here. So, if I just run this, so you can see the type is very well reflected here, date time dot time delta. So, this is about few things that we can do with the date time objects. So, now next thing is shifted date time. So, is it possible to it is also possible to shift a particular date time. So, here if we look at the dt value here, so the current dt value is this much. So, if I add the delta value that is time date time dot time delta type. So, if I add that value, so in a sense I am shifting the date time. So, sometimes in some situation this could be really useful, especially in the analytics context. So, if I add these two dt plus this delta value that I have, so I will have in result would be that I have shifted. So, in a sense this value has been lagged by that delta value that we had. So, this is about so these are few scenarios, few things that we can work that we can use to work with the built in data types that we have in Python. Now, let us move to the next important aspect, that is control flow. So, we have certain constructs in Python also just like in other programming language which can be used for control flow as well. So, we will start with the conditional logic. So, in conditional logic we typically have these keywords if, elif and else. So, as you can understand these are based on the conditional logic. So, if a particular condition is going to be checked and if it is found to be true, then the following block is going to be executed. If it is not found to be true, then if there are any other conditional logic blocks, then those checks would be performed and the following blocks would be executed if checks were found to be true as per the the statement there. So, in this fashion, based on the whether a certain condition is evaluated to be true, certain blocks are executed. So, this is what we typically refer as control flow. In a sense, the flow of execution is being controlled by certain checks. Only if certain checks are evaluated as per the return value desired answer, only then that particular flow of code, only then that particular following block of code is going to be allowed. So, let us understand the same thing with few examples. So, if I have this variable x equal to -1 and I can have this if conditional logic here. So, if x less than 0, then you can see let us understand the semantics here also. If x less than 0, then we type a colon here. So, after that whatever is the following block, it would be indented and that is going to be considered as the following block and it is going to be executed. So, if the conditional expression after following the if keyword, in this case x less than 0 is found, it is evaluated to be true, then the following block, that is the print statement that we have, that is going to be executed. So, let us run this. So, you can see because we had initialized the x variable as -1 which is a negative value. So, therefore, the conditional expression that we had x less than 0, that was evaluated to be true and therefore, we have printed this this statement here. Now, let us take another example. In this case we have initialized x as 2 and now we have we are using all the keywords that we have under this conditional logic. If you can see there is block for if, there is block for elif, then another block for elif, then another block for else. So, the difference is first we start with if. So, if that particular conditional expression is true, that part is going to be executed and other parts are not going to be executed. Now, if so happens that if was not found to be true, then we move to the next conditional logic that is typically that is typically written using elif. Again after elif also in the elif block also we will have a conditional expression again that is going to be evaluated. If it is found to be true, then the following block is going to be executed. So, in this fashion we might have more than one elif blocks. So, if none of them are evaluated to be true, then we can have one else block. So, this particular else block is like a catch all block. So, if all the preceding blocks and the conditional expression that were there in those preceding blocks, if they were found to be false, then we can have this catch all block which is the else block, where we can we can have a default kind of all, depending on the scenario, depending on the situation, we can have a set of instruction, a set of lines of code which we would like to execute in a catch all sense. So, here what we are doing is we have initialized access to and we are in the if block we have the conditional expression x less than 0. So, of course, this is going to be evaluated as false. So, the following block following statement print its negative is not going to be executed, it is not going to be printed. Then we will move to the next block which is elif block. So, here we are looking at x equal to 0. So, of course, this is also not true. So, the following block print equal to 0 will also not be executed. Then we will move to the next block, that is elif, where we are checking whether x is lying between 0 and 5. So, 0 less than x less than 5, and since this is true, so this particular block is going to be executed. So, the fourth block, that is else block, we do not we do not need to even reach to that block, because we found one elif block where the conditional expression was found to be true, and therefore, we will execute the following block or following lines of code. So, let us run this. You can see positive but is smaller than 5. So, we have successfully printed this. So, it is important. So, whenever we have these kind of scenarios, that after a certain lines of code we we have that conditional based on certain condition we would like to execute something. So, we can all the time use these conditional logics using if, elif and else keywords. Now, let us move on to the next thing. So, we can have a compound condition. So, and or. So, these are keywords that are typically used. So, these conditions are typically evaluated from left to right, and will short circuit also. So, we will see example. So, here we have two variables a and b. So, let us define them, initialize them, and then c and d. So, now we have these 4 variables, and we have compound condition where we are comparing first expression, conditional expression is a less than b, and then we have these keyword and or. In this case we are using or, and we are comparing in the second conditional expression c greater than d. So, these kind of compound condition also we can have. So, in this fashion we can write them. So, here in this example I have written if a less than b or c greater than d, then print this. So, if any of these two conditional expression are evaluated to be true, then the following line of code is going to be executed. Let us run this. So, because if the values that we have initialized for these variables, you can see 15 a is 15, b is 17. So, a is less than b. So, this is found to be true, and if we look at the c and d. So, c is 18, d is 14. So, c is greater than d, this is also found to be true. So, in this particular case a first conditional expression that a is less than b, and the second conditional expression that c is greater than d, both are true. So, true or true. So, it is anyway it is going to be executed. So, you can see reached here that particular message is printed. Now, similarly just like compound condition, we might have situation where we will have to make chain comparisons. So, in those situations also can be very well coded here. So, for example, I can compare like this 1 less than 2 greater than 3 less than 4. So, values are there. So, there itself I can check whether this is true or not. So, you can see 1 is less than 2, which is true, then 2 greater than 3, which is not true, then 3 less than 4, this is true. So, even if one of them is found to be false, then the overall the result is going to be, overall evaluation is going to be false. So, if I run this, you can see the message is the output is false. So, if there are situations where we need to make these chain comparisons, so in this fashion we can type our code. Now, let us move to the next aspect, next construct that we have in Python, loops, which is also there in most of the programming languages. So, what is the main idea behind loops? So, typically it is used to iterate over a collection. So, collection can be any list or tuple. So, few we have not gone into a detail of these sequence data types, list or tuple. We will go in more detail in the coming lectures. However, these kind of sequences or collection, list or tuple. So, if you want to in loop, typically you would like to perform certain number of iterations. So, these collection or sequence types can be used to control or to facilitate that those number of iterations. So, now we will learn about loops, what kind of loops are available in Python. So, let us start with for. So, which is typically the more popular loop that we typically use. So, here you can see the first statement for keyword and then x in this particular list 1 2 3. So, till all the values are iterated. So, this is the list 1 2 3 till x iterates over this particular collection, this particular list will keep on executing the following block, in this case just one statement print x. So, we will keep on printing the x. So, essentially what we are saying is we will be printing all the elements of this particular list. So, let us run this. You can see 1 2 and 3. So, one by one each of these elements in that particular list 1 2 3 have been printed. So, we have been able to iterate over this particular list sequence. Now, there might be certain situations where we will have to where we will have to advance to next iterations. We will have to bypass that particular iteration. So, for that we have a keyword continue. So, in that case if certain evaluation, certain let us say conditional check that we have within that for loop or any other loop for that matter, and if that is found to be true, then we can use the continue keyword to advance over to the next iterations. So, let us understand that through an example. So, let us say we have this sequence. So, this is a list and then we have another variable I. So, we are initializing at 0, then we are running our for loop. So, for x in sequence. So, all the values are going to be iterated here, and within the in the following block for the for loop we have the conditional expression conditional block as well. If x is none, then we will continue. So, whenever in the iterations that we are running for x in that particular sequence, whenever x is found to be none, we will we are using continue keyword, that means we will advance that iteration. So, the following lines of code after this particular logic, this particular if block are not going to be executed. So, in a sense we have suspended the execution of following lines of code after the continue keyword, and we have moved on to the next iteration. So, let us run this. So, after we run, you can see that value of I comes out to be 12, because if you see here we are just adding on whatever value of x that we had earlier, and then we are adding that into the I values. So, eventually the final I value is this. So, if we had not encountered none, which is the fourth element in the list here in the sequence here, then we might have got an higher value for I. So, the next thing is about loop is the break statement, the break keyword. So, sometimes the situation might require us to exit from a loop altogether. So, let us understand this scenario also through an example. So, here we have the sequence 0 1 2 3 4 5 5, and here we have initialized I as 0, and in the for loop that I am running here x in this sequence. Whenever then we have the conditional expression, whenever x is found to be greater than 4, I am using the if that is found to be true, then I am using the break keyword. So, whenever the x reaches that particular value, I will exit out of the loop. So, not just that, the following statements would not be executed, overall other remaining iterations of the loop, they would also not be executed. When we use the continue keyword, so that particular iteration, the following statements, following lines of code are not executed, and we move to the next iteration. But when we use the break keyword, we exit out of the loop. That means all the remaining iterations along with the current iteration that is going on and the following lines of code, all of that would not be executed. So, let us run this. Now, let us find out the value of I. So, you can see here it is 10. So, because here the moment we reach this 5 value that is here, immediately that break would be applied because x is greater than 4, and then we exit out of the loop. So, that is why again the value of I is on the lower side here. Now, next scenario where we can use the break statement is that sometimes we might be running nested loops. So, break can also be, so whenever we and while we are running nested loops, there might be scenarios where we would like to exit from the inner loop. So, there also break statement can be, break keyword can be really useful. So, in this case same thing we can understand through this example. So, I am running 2 loops here. So, first loop is for I in range 5 and for j in range 5. So, range 5 will actually give me those number of iterations there. So, whenever if j greater than I, so whenever the value of j becomes greater than I would like to break out of that loop, and after that we would like to within the inner loop we would like to print the combination of I and j as well. So, if I run this loop, so first the outer loop would be run starting from 0 to 4, and when the outer loop is reaching here, so within that loop when the value of j becomes 5, so it will be greater than I. So, we will exit from there. So, you can see 4 4. So, the whole thing has been printed here. So, next thing that we would like to discuss is the while loop. So, we will stop at this point, and in the next lecture we will start our discussion from the while loop. Thank you.